Okay, just had a couple questions about the graphs on Delta Math. I have a question pulled up here on the screen, and then just to the side I just have a little piece of notebook paper just so I can talk to you about it. So I wrote the equation, and we're just supposed to sketch this. It does not have to be perfect. You don't have to go to specific y values. The Delta Math is just going to look for what I'm going to look for, which is, do you have the correct end behavior, and then do you go through the correct zeros? So I just wrote down the equation that popped up on the screen for mine, and I'm going to move this so you guys can see the graph a little bit better, and we'll do that in a second. But what I've got going on here, I got to find my leading term so I can figure out if the graph is even or odd, positive or negative for that leading coefficient. So if I were to multiply this all out, x squared times another x here would be x cubed, times another x would be x to the fourth. And then this x is squared, so there's actually two more, so there's nothing making that negative out in front of any of those terms. So this would end up being x to the sixth as the leading coefficient. So this is positive and it's even. The end behavior there is going to be up, up on either end. And then I just wrote down the zeros. And remember, if you have an even multiplicity, so if this is squared or to the fourth or something like that, you're going to bounce at that place, so at 0 and 3 for this graph. And then if it's got an odd multiplicity, or like this is just, these guys are just to the first power, if it's got odd multiplicity or it doesn't have an exponent at all, it does go through the x-axis at that point. Okay, so let me grab I'm going to make the graph, just see if I can make it a little bit bigger here. All right, so kind of my plan of attack here is just to sketch this the best that I can. Now, I know the end behavior is up, up, and actually I'm just going to make a little plan really quick on my paper so I can kind of think this through before I tackle it on the graph there. So I've got, let's see, -3, I've got 0, I've got 1, 2, +3, and then I've got 4, 5. Okay, so this is totally just a sketch on my part. Now, I know the end behavior is up, up, so this is going to be up, and I have bounces at 0, and I have a bounce at 3. So I know both ends of this, oh, crud, I just drew that on the 5, sorry. Both ends of this, well, this end is still going to be up. Forgive me, it's just not going to bounce at that place. Okay, so I'm going to go through the x-axis. The 0, I'm going to bounce back down. The 3, I'm going to bounce back down, and then I'm going to go back up to go through the 5. So it's going to look something like that. So I'm just going to come over to the Desmos graph over here. So I'm trying to aim to hit the -3, and you can use your fingers. I'm just using the trackpad on mine. So I'm going through the -3 just to the best of my ability, and this does not look good, but I'm going to go back up, and I'm going to bounce from the 0. Okay, sorry guys, let me just start over real quick here. Okay, so we're going to go best we can through, from the top, through the -3, come back up best you can, and then bounce at the 0, back down best you can, bounce at the 3, that looks a little rough, sorry. And then I'm going to go up and go through the 5. Okay, now I'm going to go ahead and submit this. Hopefully they'll take it, and I know they ask you if you want to submit your answer. Yes, you do. And then it showed me I did a good enough job sketching that. Now, if you come down here, it will specifically show you kind of where it should have been in terms of how tall those curves should have been and things like that. But it doesn't have to be, you can see my graph doesn't look like that, but it does go through the correct points. I'm bouncing in the correct spots, and that's what it's looking for. So that's how you're going to do those last couple questions on Delta Math.